I wanted to kind of open this up with one of my favorite little stories. It was from David Foster Wallace. He was doing this opening commencement, and he opened it up with this little parable, right? There are these two young fish swimming along, and they happen to meet an older fish swimming in the opposite direction. And he nods at them as he's swimming along and goes, "Morning, boys. How's the water?" And the two young fish keep on swimming on for a bit, and eventually one of them looks over to the other and goes, "What the hell is water?" And it's a really good little thing to think about in this context that I want to bring in front of you here, which is, let's think about our current systems. This is our water, right? Where do you go for your email? Where do you go for search? Where do you go when you want to connect with your friends and family? And where do you go for currency? These are things that we don't even really think about anymore, right? If you want mail, you're going to go to Gmail. If you want to search, you're probably going to go to Google. Your friends and family, some kind of social network, just kind of breaks down by demographic, right? And currency, nobody questions the idea of using the US dollar as an American citizen, right? When you're abroad, then of course that changes. Just kind of thinking through what are those kind of default systems we all go with, right? When you think about these default systems, how much of an influence do you have on them as an individual? How much of a say do you get in how they operate? When's the last time that one of you got to vote in a board meeting for a technology company on how it uses your data, right? And ever think about how those systems are monetized? This is our water. What happens when those systems have an outage, right? Or they go away? What happens when they get bought by another competitor and shut down? So the problem I want to present to you is that we are enmeshed in these centralized systems. We've all grown up inside of them, and we hardly ever question their nature. I'm hoping that with that little parable I kicked things off with at the beginning, you'll just start to question it a little bit. When we think about the kind of problems these centralized systems present, there are outages, like when a network goes down. There's censorship that occurs on a regular basis all around planet Earth, including the US. There are hacks, right, when your data gets stolen. And there's privacy loss and surveillance capitalism, where there are companies that are going out of their way to collect every bit of data they can about you to hopefully resell different things toward you, retarget ads toward you, this kind of stuff, all without your consent. And this is happening every single day, every single minute of your lives as you're browsing online right now. And so here's just like a small list of examples of these kind of things that have happened in real life. And I'll provide the links later so that you can check them out for yourselves. But look at Cambridge Analytica, look at the PRISM data collection system that was done by the NSA, and so on and so forth, right? It's not like a onesie-twosie or a theoretical kind of thing. These problems exist and happen to you every single day. So what's the alternative? I'm going to present to you that I think decentralization is the alternative. And what's really wild is that it's not a new idea. Decentralization, this is about the earliest quote I can find is by Aldous Huxley, which if you've ever read the Brave New World, right, or Doors of Perception, then you would know that he's that author, right? He wrote essays, and all the way back to just the end of World War II, he was saying, as the world was kind of remaking itself, he was thinking about this, and he said, maybe decentralization is actually a better idea. He just didn't have the technology at the time to do anything about it. This is a series of charts that represent different ways that computers can connect to one another. And on the far left-hand side here, we have a graph of a centralized network. That's what happens when you all connect to one server. And so if you've ever had, at your house, right, I bet this happens on a regular basis, where the internet goes out through no fault of your own whatsoever, more often than not, it's because of your internet service provider. And they probably did a misconfiguration of this thing called DNS, which is how the word like google.com gets turned into the numbers that computers can use to know how to route to one another. This is a centralized system at play, right? But you're at the mercy of it. A decentralized system has a bunch of individual players. And so if any one node goes down, there's like a regional outage, but it doesn't take out everybody on the network, right? And then finally, a distributed system is a peer-to-peer system. Any one individual can go down, but the whole rest of the system will stay up and stay quite resilient, right? This chart, can anybody guess when this was made? I see 1935, 1960. Anybody else? Very good. What? So it was 1964. That was created by Paul Barron as he was first starting to think about how are the government and military computer networks going to survive nuclear fallout. That plan that he put in place was the beginning of what was called ARPANET and is the backbone of what we ultimately have now as the internet. The reason why the internet works the way that it works is because of the early work of these folks like Paul Barron, who is trying to say, yeah, we need to have at least this so that if any one of our cities goes down during the Cold War, we're going to be able to be resilient and the rest of our computers are going to be able to talk to each other. We wouldn't have the internet today without early people thinking about decentralization. You're right on time. So the great question was, where do we get to distributed? And here's it. So this is kind of the timeline of peer-to-peer content distribution, right? And again, I'm pointing out, this isn't a new idea. This idea of decentralization is not a new idea. It's just that we now have the technology and an ubiquitous nature enough that we can actually do something about it, right? So I think the point where most kids would think is the start of peer-to-peer is right about here in the 90s, and I'm going to point to 1999 with Napster. So Napster was a really revolutionary moment because a lot of people on their home computers could download one piece of software and connect with hundreds of people around planet Earth and form this peer-to-peer network with one another. And that was kind of revolutionary, right? You didn't need to be a hardcore engineer. You just needed to run a piece of software, right? So yeah, very good question. This is kind of the real start of what we think of as peer-to-peer. Yeah. So I wanted to take a moment and talk about like what are core Web3 values. Like Web3 is a really hot term. That's the more modern term that we use instead of decentralization or crypto and cryptocurrency. A lot of people are talking about Web3. What does that really mean? What are the values behind it? And what I'm going to posit are the values are these: decentralization, trustlessness, censorship resistance, if not censorship proof, being pseudonymous, if not totally anonymous, and being privacy preserving in general. So I want to talk a little bit about like how these systems can be trustless. And at the root of it, it's cryptography. So this is where things could get like really hairy and boring and mathematical. I'm going to try and avoid going too crazy. But we have this idea of public and private keys. A private key is something you never tell anybody ever. It's a secret. But a public key is something you very intentionally tell everybody and say, this is how you can talk to me and make sure that I'm the only person who's capable of reading the contents of the message, which is pretty clever. How many of you have ever played with like secret decoder rings? That thing where like it has like A, B, C, D, and then like 1, 2, and 3, and you can like shift them around. Right? I'm seeing some nods. You know, if you know how to match up the decoder ring and your friend knows how to match up the decoder ring, you can send messages back and forth, right? But the problem is that those systems are a little bit easy to guess. With a public key infrastructure like this, it is only you have the key to decode a message intended for you. And only your friend has the ability to decode the message intended for them. You're not sharing one common key. It's unique keys for individuals. The other idea that's at the core of all this is hashing. And hashing is really, at the heart of it, a one-way mathematical operation that you can take a file, move it through this mathematical function, and then you get a string of letters and numbers that represent what that file is. And if you try to change even a 0 or a 1 inside of that file, the hash will end up being different. It's a signature. So it's a great way of proving, is this original message authentic? Has anybody tried to fool around with it? This is the tool for authenticity. This is the tool for identity and proven communication from an individual. This is saying it officially came from me. This is the way of proving the contents haven't been fiddled around with. So I want to play around with this because hashing, I feel like, is a hard thing for people to understand in general. If you could, I would encourage you to bring out your camera phone, try and snap that QR code, and let's just see what we can do. So it's going to be a little bit of a competition, right? And what I'd like for you to do is go and visit the website. I'm going to try and do it here too. And you should get a website that looks kind of sort of like this. I can pop it back in a second. But what I'd like for you to do is type in Wursta, and then I want you to add a number to the end of it, like 0.
Can we choose whatever number?
Well, here's the competition. I want you to try doing different numbers at the end, so 0, and then 1, and then so on, like this, okay? Try different numbers until this SHA signature at the bottom starts with a 0. So try and figure it out, and then whoever, a 0. When that SHA signature starts with a 0, tell me what code you put in at the top. And I'll go back to that QR code just in case you need it.
Can it be more than, like, can it be 2 digits?
It could be 2 digits, yep. You got it? Say, okay, so we got it. Ashley got it. What is it? WRST 52. That's the one you got? Yeah. Okay, let's test it out. So I got, it starts with a 5. Yours starts with a 0?
No, she said 52. Oh, yeah. I put a capital W.
Oh, okay. So that'll be different. Yeah, so there you go. Notice that little difference, right? A capital W, a lowercase w, they actually encode differently, right? So Ashley might, yeah, so I wanted to explain this to you because people have a hard time understanding what does it mean to mine a block, right? When you're mining a block, what you're doing is you're taking the content of the transactions, this set of ordered transactions, and then you're adding a number to it, just like we just did here with 52. That's what you're doing. That's a number that you only use one time. And the word in the industry for that is the nonce. You iteratively read through those. So you do like Wursta 0, Wursta 1, Wursta 2, Wursta 3, Wursta 4, Wursta 5, until you get one that starts with a 0, okay? The number of zeros at the beginning there, that's what's called the difficulty. So in a proof of work system like Bitcoin, what they will do is they'll see, we want one block to show up every 10 minutes, roughly. If a block comes too early, then they're going to say, okay, the next block that comes in, we want you to have 2 zeros at the beginning. Guess how much harder it is when you have 2 zeros at the beginning? Yes. So we got some nods, some people saying a lot, and yes, that is true. The answer is a lot. It's actually a lot more effort to get 2 zeros instead of 1 zero. And if you want to, I mean, try it out, right? Like, absolutely try it out. And sometimes you get lucky, right? But in general, you're going to find that adding 2 zeros at the beginning is pretty darn hard. And if you added 3 zeros at the beginning, it's probably going to take you months, right? But this amount of zeros at the beginning is going to shift, right? So if it takes you too long to make a block, and it's taking you much longer than 10 minutes to make a block, I say, okay, so Ashley is the equivalent of what we would call an ASIC miner. She obviously has something figured out here and is really great at mining. But this is kind of the core idea of what's happening with mining is you'll have an ordered set of transactions, you'll have a number that you put at the beginning of it, and you're trying to get a signature that starts with the appropriate number of zeros. That's your difficulty. Okay? You now, is there anybody where this feels fuzzy? Okay, let's dig in on that for a second. What else? What's feeling fuzzy?
I understand it's like trying to be more secure.
It's trying to be more secure. Yep.
I get that, but what are we securing?
So what are we securing? Great question. Okay, so when you have a set of transactions, you want to be able to make sure that nobody can lie about the transactions or reorder the transactions, right? Yeah. You want to make sure that nobody can reorder the transactions or lie about the transactions, right? And so it's a little bit important to make it difficult enough that somebody is going to have to spend a lot of effort to try and do that.
So is this like a different layer of encryption?
It's hashing, but yes. So yes, right.
I understand encryption, so this is just the Web3 version?
So when we talk about mining, we talk about it being a race, right? In a proof of work system, it's a race between individuals to solve a hard math problem.
Yes.
That's the hard math problem that you're solving, is can you order the transactions and can you find that number to use once, fast enough, faster than the other people, and submit that as the block.
Okay.
Yep. So you're in a race with other people to try and order a set of transactions, use a number once, hash it, and if it has the correct number of zeros at the beginning, you submit that to everybody and say, hey, I think I've got a good block here. What do you think? And if you're faster than everybody else, then you win. You win the block reward.
Okay.
That's how the mining mines. Yep.
Okay.
We'll get into a little bit more detail on that and recap it in like the second presentation. But yeah, I wanted to kind of give this a try to let you just have like a bit of a real world example of what would mining look like at its basis.
Well, we're glad Ashley's here because otherwise we'd still be trying.
Yeah.
Yes.
Super fast, yeah. If you did lowercase Wursta, I think you would have found it by the number 5. But you did just fine. You did a capital W and you did just great. Yep. Okay, so what else is a core value, right? Censorship resistance is a really important thing. We don't want people to be able to like stop somebody else from doing a transaction. Everybody should be able to participate equally, right? So what are some tools in the censorship resistance toolbox? Up until recently, I would have said GitHub for sure. I made sure to add radical.xyz to this as well. And the reason why I say up until recently is because GitHub took down the source code for Tornado Cash, and that's a cryptocurrency system that is used to mix up transactions, kind of hide who owns what. And in at least the US, open source code is considered free speech, and it's actually protected by law. So when GitHub took that down, that was actually a really controversial move. And but I'd still say, nonetheless, open source software is one of these critical components of censorship resistance. You want to make sure that everybody has access to the code, can audit it, can run it. So Napster, a piece of software everybody had, they could just download it and run it. Open source software, not only can you download it and run it, but you can actually make changes to it, or at least submit and propose changes to it, and those can get accepted by the larger community, right? Another piece of censorship resistance is pseudonymity, right? So this is this idea of your identity is not, like in my case, Alex Wykoff at Wursta.com. It is 0x1213, like so on and so forth. That you're not knowing exactly who you're dealing with in terms of their, core physical identity.
Couldn't that also be risky?
So the question is, couldn't that be risky? So give me an example.
I don't know, like if you don't know who you're dealing with, then it could be, you could be like a hacker or, I don't know.
That's right.
Black web or
Yeah. So if you don't know who you're dealing with, there could be problems of fraud, scams, this kind of stuff, and that does happen, right? On the flip side, there are mechanisms that you can use in your favor. So there are escrow systems and whatnot that, yeah, exactly, that it would, you would be able to make sure that both sides of the party are being, holding true to the deal. Yeah, absolutely. And then, whereas I might know you and you might know me, because we're using these pseudonymous identities, anybody observing the transactions from the outside wouldn't necessarily know who we are. Versus, say, what's that one payment system that everybody's using nowadays that's like casual? I'm thinking Venmo, maybe, right? Venmo, doesn't they have that feed that shows like, oh, hey, this person paid that person, right? That's a little bit intrusive. But that's public, the way the blockchain is public. It's just it has the identities. It's not pseudonymous, right? So, but we find that to be intrusive, right? Exactly because of the idea that it's not pseudonymous. So another piece of censorship resistance is being peer-to-peer. The idea that you have like a non-hierarchical relationship between you and the other participants. I'm running a computer, you're running a computer, we're all networking together, and there's no one person in the middle who can flip a switch and just turn it off, right? That's a really big deal. And we find that across planet Earth, if you're not working with a peer-to-peer network, then you can actually get into pretty big trouble. We've actually seen like countrywide shutdowns of the internet, right? How many people have seen that in the news? It's in the list that I showed earlier in the presentation as well, right? So Orlando just asked, can you give some examples of where we should be peer-to-peer and we're not? I would dare say DNS is one of these ones that we take deeply for granted. Like at the beginning of the presentation, I said this is water. We take DNS entirely for granted. And that's kind of a scary thing. This idea of like, nobody around here is going to memorize their friend's phone number, let alone an IP address. So how are you going to route to that person if you don't rely on DNS? Yeah, so that'd be one like just off the top of my head. There's plenty more though. Yeah. So moving on from core values of Web3, I want to just talk a little bit about growth. So this is just over the last year or so. We see that Ethereum has about 205 million addresses. Brave, the browser, has over 50 million users. MetaMask, which is the wallet that we're encouraging everybody to install here, they have over 30 million users. Hopefully they get a few more tonight. And then OpenSea has over 1.5 million users. And these numbers are way up from even just the beginning of the year. So holler at me at the end of the year, Christmas time, and ask me to give you an update on these numbers, and you'll be really surprised. So what are some implications here? Web3 isn't just about like cute profile pictures that you see on the screens around us here. It's really going to fundamentally change the way that we do business with one another. And if we happen to take a close look, I think we have some really interesting outcomes that we could see happening to businesses.
Do you have some examples of how this could apply to a real-world use case?
So the question is, do we have some real-world use cases? And I'm going to get to that in just one second, for sure. First, though, I want to just say that businesses are about to fundamentally change. Some are in that process already. And it really is a testament to Wursta and Matt in particular, who's kind of sitting in the middle of the row there, about being willing to be forward-looking and to open up this R&D wing that we have with WRSTCollabs to be on the forefront of this and to help service our clients going forward. So here are some near-term implications, just off the top of my head. One is reputation systems. We've just seen not only Reddit, but also Starbucks roll out their system on Polygon. International funding transfers. This is already happening with core blockchains, remittances, right? It's incredibly cheaper to send Ethereum over the wire, even with gas fees as they are, than it is to do a wire transfer. We have ticketing. So if you're going to an event, you can show that you're holding the NFT or whatever particular ticket it is, and you can do that using your phone. The sales of those tickets can be a lot more fair, so that they're not getting like pre-sold out shows and then getting scalper prices. We have exclusive merch, and our partner Round21 is actually doing a really great job of this, which is how do you give somebody a unique experience that's related to their cryptocurrency activity and their NFT holdings. And fractional ownership. This was something that Petros and I saw more of in New York City during NFT NYC, but it's this idea of how can you have a bunch of different people owning a piece of something, and that piece of something really was on the range of like from artwork to living horses. Like they had horse racing horses, and you could actually have fractional ownership of these like living, breathing animals, which I was utterly blown away by. So Michelle had a great question. What happens if they die? So I would imagine in the fractional ownership of a living, breathing horse, if it dies, your value goes to zero. But you know, you got kind of liquidated at that point. So yeah, here's some sources and whatnot. But yeah, that was just the first presentation, which is at a high level. Why does Web3 matter? And hopefully that kind of just wetted your whistle a little bit.